Hello everyone, very good evening and welcome to interview preparation session. Welcome to 360 degree TMG and let's start for the day. Okay, so first of all, so what do you mean by cross validation? So the name suggests we know that whenever it is in imbalanced data sets, when you want to give better training on two classes or multiple classes, the best option we have is cross validation technique. It's a technique to test whether the given machine learning system can perform accurately over data sets, right? And the one what we have used for training it, right? So programmers definitely, they split their data, right, to two different sets for cross validation. And one more biggest important point, biggest thing which we have to consider for cross validation is you will go for this cross validation when you have huge tuning the parameters. So use it to train the data, right? So whenever you're cross validating it, there are many techniques to do this, not a single one. You can go for stratified, you can go for k-fold, you can go for leave p out, hold out method. So generally when you go for normal things, like you have hold out method, which is one of the sampling technique, what we do, generally it is like your train and test. You just divide it. There is no further split is happening here, right? But whenever you are trying to use as a hold out method, just train and split, nothing like, you just give training on this, you predict on test data, that's it, right? So when you go for k-fold cross validation, which is one more way of giving training, better training to your data, you divide your data into the number of paths of your choice. So how do you divide it? It's like k is your choice, k is equal to 5. So when you divide this, each of the data set, only the training data set, okay, will be divided into 5 different parts. So 5 folds. Each time, so it will run for 5 iterations. First iteration, first 4 points or 4 sets will be taken as training, and it will be tested on the corresponding leftover one. So this happens in the first iteration. When it comes to second iteration, right, this second iteration P1, P2, P3, P5 will be there on one side. Whatever P4 will go for test. Then P1, P2, P4, P5 are on the training part. One part of it will go to this. Like that, when 5 iterations happen, P4, P5 is tested, P4 is tested, P3 is tested, P2 is tested, and P1 is tested. It is your choice how much cross validation you do. So this is a technique which many of the machine learning algorithms, they have inbuilt. And whether it is XGBoost algorithm, which is having the cross validation technique inbuilt. Right? Generally, we use grid search CV technique where we are using cross validation as a part of, and this is going to help when you have imbalanced data sets. Right? This is one of the technique where we can choose. So further, if at all we want, we even take leave one out method or leave p out method. There is also one more. Okay? Leave p out cross validation. What does this leave P out? P is something what you decide. If P is equal to 1, you call it as leave 1 out cross validation. Out of all the data points, one data point would come out randomly. You are giving training, you are testing on one data point. Again, you take the data set, one is coming out, you test, you give training. So though it is taking, if you have 100 data points, you are giving 99 times training, you are testing all the data points one at a time. It's exhaustive, but still people use when you have very, very small data sets. Not like huge data sets, small data sets, and this will work. When you say P out, P could be anything, P is equal to 5. So 5 data points would come out and will be used for testing. P is something what you can give. Well, it is stratified. Definitely, yes. Stratified sampling, same concept. Stratified sampling, stratified k-fold also. This particular proportion is taken and it is divided according to k, which is equal to 5. So equal proportion, 5 parts. You are having 100 or 20, this one. So if you are dividing it 5, right, like this, 25, 20, where it is 25, right? This is 25. So you will get 5 here, 5 here, 20 here, 5 here, 20 here, 5 here, 5 here. It will divide according to the proportions, which is nothing but stratified K4. Okay, this is our cross validation. Okay, the next thing here is when we are working out for evaluating any model, when you want to evaluate a model, right? What are the metrics and how do you choose the metrics here? Metrics here are very, very important because we are evaluating a machine learning model. Selection of metrics, it depends upon various factors here. So first thing you check whether you are running a regression model or a classification model. That is dependent. And how do you choose a classification model or regression model? You check with respect to your target variable. Your Y is your interest. Based on your Y, to decide whether you are going for classification or regression. Based on classification and regression, you have the evaluation metric decided. Different algorithms here, right? So when I talk about regression, what are the things I can go with? I can go for mean absolute error. I can go for mean absolute percentage error. I can go for root mean square error, or I can also go for mean square error. All this errors, because when you want to work with loss function or cost function, error function, all mean the same for regression. So that you can call it as loss or cost or error function, all mean the same. There is nothing like how do you calculate loss with respect to regression models. It's the same. Loss or error is the same here. But when it comes to your classification models, what is the evaluation metric we will follow here? We will go for confusion matrix, or you can go for cross table. It's confusion matrix or cross table. About cross table, contingency table, where you have actual values, where you have predicted values, but based on that you're calculating your accuracy. You will have something called as recall. You will take precision, a trade-off between recall and precision. you go for F1 score. Right? These are the most commonly used. But when it is classification, we are not restricting ourselves for confusion matrix or cross table. It is a concept of your false negatives and false positives being least. So depending upon the different business problems, there could be scenarios where false positives are important and there should be decrease in the count of false positives. There could be scenarios where false negatives should be coming down. So it changes, it is not fixed here. Right? So even though you have a very good accuracy, you have an accuracy of 75, 85 or 95, whatever may be the number here. Right? It is something that depends upon the business problem. You have to check the false negatives and false positives. Look at false positive and false negative. So check for the cost of different classes for misclassification. Right? There would be for example, there would not be an earthquake, there would be an earthquake. Loss of life, property, cost is what you are taking into consideration. We need more training data on earthquake occurrences. The instances where earthquake occurrences are more, they should be there. So more patterns should be learned for your algorithm where earthquake scenarios are more. Right? Suppose you have non-earthquake as 10, earthquake as 100. Maybe you have to give more improvement is required for this because for that scenario, this is not accepted. You cannot say when this earthquake will happen, you are saying, no, it's not happening. Okay? This is something we focus when we are evaluating classification models. False positive and false negative. How can we explain that? When you're talking about the contingency table, when you're talking about this, what are false positives and what are false negatives? So false positive is like a false alarm, where the model suggests that the presence of a condition even when it does not exist. A false negative is exact opposite of the situation what we have understood, where the model suggests that the absence of a condition when it is actually present. Both are false, right? So we can't say that which is more dangerous, which is less dangerous. Both are dangerous. It might change with respect to your business problem. With respect to your business problem. Okay, then. Error, poor metric, error or MSC, right? It is based on, it is associating a higher weight to large errors, right? And you're putting greater emphasis on your wider dimensions. Right? Most of the algorithms, the main aim is to minimize the model error. So a better option somewhere is mean square error, right? Better option is we have to go for MAP, right? Which does away the whatever the shortcoming and whatever the easy way to interpret things are easier, because mean square error is you are taking your actual value, you are taking your predicted value, you are just taking error of a square of it, taking the average of it. So when you take this, your units are getting squared. Maybe if it is volume, whether it is miles square, whether it is a dollars square. So to get back to your units, you are doing this. So it is becoming RMS. Right? This is better. If it not, you will go for mean absolute percentage error, where there is no constraint here, whether you are working with dollars or whether you are working with rupee. Same, but the way we are representing it is different. So such scenario, someone working for US, someone working from India, right? If at all your comparison is happening, this is best, right? If at all your units are getting squared, RMSE is best. So you make sure that your model is not overfitting. How will you make sure that the model is not overfitting? Reasons that cause overfitting is that the complexity of the model over, more pattern learning is happening with the trained data, and your model is not able to generalize it on the test data. Maybe the amount of noise which is getting mixed up in the training data, that is the reason that your model is getting overfitted. So just now, as we have discussed, cross-validation methods like k-folds can be used to curb this problem of overfitting, right? And the most very famous is our regularization method. It can be used to penalize the parameters that might be causing overfitting, right? So when we talk about the regularization, right, every algorithm, whether it is Knight-based, parameter here is Laplace. When we talk about KNN, the regularization parameter is K. When it is decision tree, the regularization technique here is pruning. Whether it is your ensemble techniques, ensemble methods, bunch of parameters are there which will avoid overfitting. Maybe like maximum depth, right? Minimum number of features, maximum features, CCP underscore alpha. Right? Bunch of things are there for ensemble models. So when you go for regression techniques, you will have L1 and L2 norm. For this or regularization techniques, which will help us to do this. Saying that we are talking about machine learning algorithms here. How can we explain that? How is ML deep learning? One such statement which you can explain to a layman, how is machine learning different from deep learning? They don't know anything. They are just new to it and they want to know what is the difference between ML and DL, deep learning, and this. How would you explain him in a simple way? If at all I have an input, right? I have an input. So I have to do action. I will build one classification model. A classification binary output, whether it is a car or not car. This is happening in machine learning. So what did I do in machine learning? This ML is focusing on analyzing, learning from the data, learning the features, extracting the features, fed into the model. Using those insights, I'm trying to make a decision. This is your ML. What happens in deep learning? So this is our ML. We have a small circle, which is our deep learning. Basically, it is a subset of ML, right? So the deep learning algorithms, they are influenced, they are taken from the architecture of a neuron, inspired by human brain. So it focuses on feature extraction, the same car image, if you pass it, right? All the things, these two things are happening here only. There is no special command required here, right? The classification happens and you get the output, whether it is a car or not car. So automatic feature extraction, it focuses on feature extraction by reducing some information from multiple layers, where each layer propagates the information to the each other layer, forming a dense network here for the final outcome. We can differentiate ML from deep learning. You have to focus here is extract is happening, how we are doing EDA, all that matters a lot in machine learning, because under your supervision, it has to learn the patterns. So, it's very, very important that, the stages of any model development, which should happen in machine learning project, right? The very first day we will start the project management methodology, right? Development. You will have to define a business problem. Right? When you define your business problem, the client would explain you things, right? Whatever he explains, maybe he knows what is the exact thing he want to, right? This is the best in ML domain that, we are going for project management methodology, which is a crisp MLQ, right? So you understand the business problem. Sometimes, people are mature enough that they know what is the requirement. Sometimes they don't know. You have to take the insights from the customer. The customers feels that this might be the business problem, but that could not be the business problem. So convert it analytical problem, what it is, right? So you have to do, so suppose we are doing any project for some one particular country related to post bank. So what it will be, what we have to do, what are the challenges we are facing, right? You want to improve something related to post bank. So something related with banking industry. So you might have whether it is developed or not developed, where you want to launch it, right? We have to do a lot of research here. So you're starting the journey, defining a business problem itself is that, it takes a lot of time to understand it. Then you construct your data, you identify the required data sources, you extract, you aggregate data at required level, then start your EDA procedure. Then you prepare your data. When you do EDA, again, so many things are coming into picture. Check for the assumptions, identify the relationship between different types of variables. Okay? You prepare your data, do outlier treatment, do create hypothetical relevant variables. Right? Whether it is related that you have to create dummy variable creation or not, bending the variables. Then you do feature engineering. So to avoid multi-collinearity, you have to optimize your model complexity by reducing your input variables. Whether you have to perform PC on top of it, whether it is a combinational model, it's a cocktail model or not, right? Whether you are trying to find out the variable clusters, you are trying to do factor analysis on top of it, or you do PCA, or any other unsupervised learning algorithm is implemented on it. You fix it, you prepare it, you extract the features, then you split your data. Sometimes, as we have understood, right, when you are doing suppose if one of the student is from one of the what you call it as a project, right? He is working on a project called as inverse cooking. Given an image, if an image is given, input, the output should be what is the name of that particular recipe, what are the ingredients that people have used it, what are the instructions to cook that, right? So all the steps should come sequence by sequence, right? So such things would come into picture, right? Then you fit your model, you check the accuracy, you again cross validate, you do tune the parameters, then evaluate it. Then you have to monitor and check the maintenance. So with the data set, whatever you have collected, the data, whatever you have collected is of different format, right? It is from Excel, it is from text, it is an image, it is a PDF format, right? And you are using different databases to pull in, right? That also you have to check, right? So when you have the robustness also should be checked. Suppose you have your data collected, if you have collected age, okay, for around 18 to 32 years, and the income you have collected is from around 80,000 to 78,000. So you should be making a statement in your charter saying that, see, the model will not work less than 18 and greater than 32. So it is not going to give me the better results if you are giving a data which is less than 18 and greater than 32. Once in a while, if the age is 40 years, sometimes it may work. Luckily, it might work, it might not work. If it works, the robustness is more, else the robustness is less. Robustness can be increased while simulating something uniformly, right? Randomly, there should be some uniform numbers like 1 to 5 randomly is added to the data. 18 plus 3, 21. Some number is what you are going to add. Whenever you are building a model, you have to think about the scalability also, right? So when you test, suppose for example, scalability in the sense you have to talk about the chatbots, right? So how many people, if at all you have built a chatbot a year back, few years back maybe, so you will check how many people are using that and how many people can access it parallelly is what you will check. Suppose 600 people are using it at a time, right? For the next 1 year, we can build a model where it is 1,000 people can access single go. In a single go, they can access. So after a few days, if they want to launch and a new product with new regulations, so they want to add a new question, launch it, and get more attraction to the chatbot. So this was on maybe we can say budget announcement day, for example. So suddenly after 1 hour, 2 hours, 3 hours, number of users eventually increase drastically. What will happen? the chatbot will stop responding to it. So what will happen? The person, the brand image of the company will come down. That's scalability. When you're building any model, you have to not only check the hardware resources, software resources also should be checked. Maybe you have to go for model compression, quantization. Everything has to be done properly so that it is not stopping this issue. It's not making this issue very, very complicated. So you should have a clear cut idea of what is going to happen. Right? Okay. Then someone would ask you, they might be asking when you're explaining this, maybe when your project work is explained, maybe. So what is that you will be, the next question will be, what is your favorite algorithm? So whatever algorithm you're trying to prepare, right, it should be, you should have clear cut, good explanation capabilities about the project. Yes, no, not like that. Everything should go in a flow. It should be your favorite algorithm. Right? If someone asks you, if suppose you say your favorite algorithm is logistic regression, so how will you explain a logistic regression from a layman perspective? How can you say that why is this? I'll go for this. How do you explain all those things? So it's a technique used to forecast a binary outcome, right? From a linear combination of different inputs or predictor variables. So it is also called as logic model. So you should explain him giving examples saying that predicting whether a sports person will win a match, it is a binary outcome, right? So the predictors, the inputs here, we can use it as the time spent in training, the health of the player, etc. So when you talk about the technical terms, logistic regression is establishing a relationship between a dependent variable against various independent variables. It is something that you are explaining that why being discrete, why is happening this, there is an S curve, right? If it is logistic regression, why it is called as a regression when you're doing a classification for a binary outcome? That will be a follow-up question for us. When we are talking about regression, we know that y is numeric. But why still you're calling it as a regression? Why not a classification? You've got a logistic classification model, right? So here what is happening? The output what you are getting for logistic regression happens to be a probability number. It is numeric in form. So because of that reason, though it is doing a classification, right? We call it as regression because the interpretation capabilities are there, right? And then the output is the probabilities. Probabilities is what we are getting here. Then, how regularly should you update an algorithm? How regularly should you update right? So when it starts to show inaccuracy, underperformance, right? So maybe this could be because of your data source or population itself is changing, your data is changing, right? You are trying to find out, you have to evolve through the changing infrastructure, business context, data pipelines, all these need to be checked, right? So then we can take a call on updating an algorithm or doing certain changes to our algorithm, right? So we all know that data science, right? And what is the goal of data science, right? So when we are talking about machine learning, In that, again, you are talking about supervised learning, again, unsupervised learning. And we are talking about deep learning. In that, again, you have reinforcement learning, right? Though you have a very, very powerful algorithms like neural networks, but still we are using machine learning algorithms for few scenarios here. Few business problems can be solved using machine learning algorithms. Why? So machine learning is attempting to provide the computer with an ability to learn, right? Without providing very, very explicit instructions. Deep learning, which is being a subset of ML, it is trying to mimic the functionality of a human brain, right? Reinforcement learning, which is based on a penalty mechanism of the human mind, it will map situations to the actions, and the end goal of the learner is to take a decision and to maximize the rewards, means to minimize the error and maximize the accuracy. So when we are talking about machine learning, the interpretation capabilities of few algorithms is excellent when compared to deep learning. For example, whether it is when you are deleting one particular column or when you are deleting one particular observation, you need to, if at all, you should have a good clarity on why you are doing that. When you are running a deep learning algorithm, it's a neural network, right? There is no particular scope of understanding things, because automatic feature extraction is something which is happening, and you don't know at what layer what features are being learned, how the pattern is being learned at what particular layer, because it is totally different architecture and we cannot pull information from each and every layer. It's just giving an input, getting the output. In between what is happening, we are clueless. So because of that reason, still we have few algorithms like decision trees for classification models and regression, linear regression, logistic regression, where the interpretation capabilities are very high, that still we are running these algorithms for interpretation, for checking R square, for checking adjusted R square, right? For decision tree, for checking entropy, right? Gini index, information criteria, information theory. So these are the things which you cannot interpret. We are clueless what is happening at what stage of any algorithm, which is ahead of machine learning, right? Okay. Suppose now you have a 4 GB RAM and you need to train a model on 10 GB data set. What would you do? You have 4 GB. Okay, my bad. You have 4 GB RAM, but you need to train a model on 10 GB. Is to understand different types of ML techniques, their pros and cons. Right? Some techniques can have a good fit even with less number of samples, whereas you need a large sample for optimum performance. Right? So for example, as we are talking about the deep learning algorithms, neural network, batch size can be undertaken. For SVM, a partial fit will is good enough, right? And few times we have a very famous now, we are using Google Colab to pull in the data to work with huge data. But more often than not, when you're faced with this, right, you should be understanding the things like, many techniques are there, right? So you should start answering the interview that what could be, it would be different for different business problem. If the business objective is operational or it is strategic, how will the model be implemented to solve a business problem? Which algorithm will suit the capability match with the requirements, right? So if these questions it's easy for us Right? So few preliminary questions is what should be answered. Right? There are wide range of business problems, wide range of algorithms that can be used, making it important to understand the relationship between your algorithms and various kinds of business problems, which will help you in choosing the right algorithm, which will lead to good results. So whatever we have, as the size of the data is increased, so the methods of handling the data also increased. The data and its related problems are domain specific, business specific. So the most common methods of solving data-driven problems, include even deploying the knowledge of machine and AI to gain some insights, some patterns, some predictions. Right? So you have bag of algorithms, numerous machine learning algorithms, right? So you just talk about the business problem, whether you're doing forecasting, whether segmentation can be applied, can optimization can be done, right? Whether you are just running an unsupervised and then top of it, you're learning a supervised learning. And whether it is a combi of supervised and unsupervised, right? Whether it is a long to mid-term objective or it's a short-term objective, right? Whether accuracy is important or interpretability is important. All these things have to be focused when you have huge data, right? When you can you work on sample of data or not, right? Especially now you can say that yes, Google Colab is the best solution here. Okay, so we'll stop here. Thank you all for joining in. Thank you.